Let me record this. All right, so we have angle E equals angle R, and EN equals RA. Then triangle YEN is congruent to which one? I've seen this problem. Can't remember which student I had that I saw it, but it's a little tough to prove if I remember right. Let's see, that's E, M, N, Y, A, and R. So, ooh, no, I didn't draw it right. I don't have this, I don't need this line right there. And angle E is equal to angle R, and EN is equal to RA. And they want to prove that YEN, this triangle right there, we're going to try to prove it equals to YRA, because that's where we have all of the information. Now, let me think. I have to, let's see, we know angle, side. What do we know here? In other words, what's the next piece of information that we can say?
That y is congruent to itself. Like y and y.
Well,
or R, Y, A, and then N.
Yeah, in other words,
R.
that's vertical angles. So
Yeah.
those two angles are congruent. Okay?
Mm-hmm.
And now I have angle, side. Now, angle, side does not always prove congruency. It has to be the corresponding side. And the way you find to make sure it's the corresponding side is this side that has the hash mark is opposite this double hash mark angle. And this side AR that has the hash mark is opposite that double hash mark angle. So EN is the corresponding side of those two triangles, in which case angle, side is proper.
Mm-hmm.
Now, there is, I saw a slight variation in this problem. It wasn't quite the same one. The one I saw, they were trying to prove this big triangle is congruent to that triangle, which they are also. But that's not what this one asks. So let's go on to the next problem. Do you have any questions about this problem?
I think I understand it.
Maybe I don't need to draw this one. Man, I can barely see it though. There. So we have G equals A. T is the midpoint of IS. Now I'm going to have to draw it. I don't do well on these ones unless I draw them and can start labeling them, in which case then I can kind of work out stuff. That's T, and that's, what's that letter? I?
Mm-hmm.
G N R Y A S. If angle G equal to angle A, we have T as the midpoint of IS, which means what? How can I label those?
You can put tick marks between T and I and then T and S.
In other words, if that's the midpoint, then IT has to be the same length as TS. Okay. And finally, they say YTS, this angle here, is the same as NTI, this angle here. All right, now we're trying to prove something about triangle GTS. Well, clearly, what we're going to try to prove is that GTS is congruent to this triangle, right?
Mm-hmm.
GTS being in green. In other words, they look congruent, right?
Yeah.
So obviously that's what we're going to try to prove. Now let's see, what do we have? We have one angle. We have one side. We have two angles. But one of our angles, I see how we're going to do this. Let's see. Do we know what angle ITA? Here, this is a little tricky. We haven't seen one like this. This angle right here that I'm going to label 1. See?
Mm-hmm.
GTA.
Mm-hmm.
That's not part of the two figures that we're trying to prove are congruent to one another, right?
Yeah.
Okay, but it is equal to itself. Okay, which means since that's equal to itself, this angle, which is part of the triangle in red, has to equal this angle of the green. You see why? In other words, if I call that angle 1, then this angle plus 1 has to equal this angle plus 1, because that angle is equal to that angle. I don't know if I made that perfectly clear. Here, let me see if I can draw these a little better. I'm going to number them. That's angle 1, that's angle 2, and this is angle 3. Okay? And what they've told us is that angle 1 is congruent to angle 3, right?
Mm-hmm.
Which means angle 1 plus, in other words, if 1 is congruent to 3, then 1 plus 2 has to be congruent to 1, or 2 plus 3.
Mm-hmm.
By, which property is that? You're not proving this anyway. Well, maybe when they say why, I'm not sure how much of an explanation do they want, but I think that that's the, what property is that? I'm not sure that we need to know, but as long as you understand the logic. In other words, if I say that A equals B, then A plus C has to equal B plus C. Because all I'm doing is adding C to both sides. Well,
Yeah.
that's what we're doing here. we've said that angle 1 is equal to angle 3, and I'm adding 2 to both sides. So I suppose that would be, that must be the additive or the addition property for algebra. And once you show that 1 plus 2 is equal to 2 plus 3, well, now we have angle, angle, side, and it is the corresponding side. So again, by angle, angle, side, this is going to be congruent, and that's probably all they want for the y. Is angle, angle, side, is my guess, right?
It doesn't say, but I'm pretty sure.
Yeah, it's hard for me to believe that they want you to put a 2-column proof in there.
Or I would be very annoyed.
Yeah, although the y part is not that obvious, because this is the first one I've seen where you have to use this additive property down there. And you might even have to say 2 is equal to itself, the reflexive property. But as long as they've told you 1 is equal to 3, then you know that 1 plus 2 is equal to 2 plus 3. All right. Have a look at 29. Yeah, that looks familiar. It's the same drawing. I wish I had never erased it. Oh, maybe I can get back to it. Sure. Perfect. And same letters even. Good. No, not the same letter. Oh, yes. Yes, it is. Let me erase some of this stuff. Okay, let's see. G is equal to A again. G, Y, A is equal to ANG. GYA, that's that angle there, is equal to ANG, this angle here. And GRN, so here, I'm going to draw this in blue. This is the one we're trying to prove congruent to something. And let's see, what other colors do I have here? How about and obviously going to try to prove that it is congruent with this one. Now my drawing certainly doesn't make it look like they're congruent, but and they've given us 2 angles. Then we do happen to know that the third angles are congruent also, right? In other words, the third angle here is a vertical angle with this. So we have 3 equal angles. Unfortunately, that does not prove congruency. So we have to do something else. Erase that and that and that. Well, let's see. We can't do anything with just sides. We're going to have, or I mean with just angles. So we need a side. We have to prove that one side is equal to another side. I'm thinking, yeah, what to do. There's no side here that's the same side for different triangles. Oh, yes, there is. That's IS. IS is the same side for two different triangles. The same side for ISR, and it's the same side for ISR and the other triangle that thing makes up. I can't see it. Maybe that's not true.
Well, could you do like R and Y and like R and N because of like, I don't know why.
No, I think you're on the right track. In other words, we're not going to be able to prove anything with the blue and the purple triangles until we figure out a side.
Yeah.
And how are we going to figure out? They haven't given us any information about sides. So what I'm thinking is we have to prove two other triangles are congruent first. And once we do that, then we'll know that well, let's see. One of the sides of those other triangles has to be one of the sides of these two triangles. I don't see it. Now, there's no way, is there, that the conditions for 28 apply here? In other words, I assume that we cannot presume that T is the midpoint between I and S?
I don't know.
I would say not. It doesn't seem to me to make sense to number these different problems and then have the conditions for 28 apply to 29.
Yeah.
Nah, sometimes it helps. I'm going to try it here, but it helps if you sometimes draw the figures outside. In other words, that's NGR, and that's what we're trying to prove is congruent to this one. R, Y, A. And at the moment we know that that's the same as that, and we know that angle that is the same as that. In fact, they don't give us any information whatsoever about any side lengths here.
It cannot be decided.
Oh, it can be that?
Yeah.
Oh.
I'm assuming, because if they didn't give us enough information.
They didn't give you an answer, so that might be the answer. Here's what I'm thinking is that nowhere here do they give us any dimension or any information that allows us to say that one side is equal to another side. In other words, the previous problem, we could say that IT was equal to TS, and that led the way to solving the problem. But you got to have at least a side. If you think of all your rules for proving congruency, you got side, 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 angle, side, angle, angle, side, or hypotenuse length, which is two sides. So you have to have some information about the sides to prove congruency. I don't think you can do it otherwise. Now, we could say that TS is equal to itself, and TS is part of the green triangle, but then it's really not part of any other triangle by itself. So I'm inclined to think that this one cannot be proven, and mainly because if I could move T, In other words, it certainly looks congruent, right? But that's
Yeah.
just the way they've drawn it. T appears to be the midpoint. But if we slide T up a little bit, of course that changes this angle, but you could change that angle so that it's the same if you change some lengths. So yeah, I don't see how we're going to do this.
Yeah.
Let's go on. This one here I know how to do. I've seen this one. Wow. How is it that I've seen this one? I never saw that one, other one, 29, and didn't see before. EBC is congruent to ECA, and AB is congruent to CD. Yeah, this is another interesting one where this is congruent, I remember. And it's by a similar strategy. Here, E, B, whoops, B, C, and A and D. So ECA is congruent to EBC, makes that an isosceles triangle. It means that's congruent to that. And AB is congruent to CD. So now we have the fact that this angle is congruent to this angle also means, since that's supplementary, that has to be congruent to that angle, right?
Mm-hmm.
Angle ECD has to be the same as EBA, and now you have side angle side, BAE. So BAE is going to be congruent to CDE based on side angle side.
Okay.
Oh, yummy. The bottom one. These are always lovely. Actually, they're not bad. They really aren't. Let me see if I can get it a little bigger. The one thing about these kind of problems is you don't necessarily have to go in order. In fact, a lot of times you frequently cannot go in order. But on this one here, I have done this one. That makes me think that other one that we couldn't prove, that bothers me.
Well, your Jack does different things than other teachers.
Yeah. Okay, so let's start on this. I'm not going to draw this. That would take the whole 4 minutes, and I think we can answer it right away.
Mm-hmm.
Let's see. Do we know angle I?
You can figure it out.
52. Go ahead and write that on your sheet. And if angle I, was this the best way to do this? Let's see. Let me think for a moment. There's other things we can figure out here more easily. Let me think what they are. I guess we can do it this way. I is 52. And if this angle on the lower left is equal to this angle on the lower right, then that's 128 divided by 2. Those are each 64.
So then A would be 64?
Now, notice that that's the vertex of that triangle right there. So that's 64. A is equal to this one.
Oh.
Okay, so subtract 64 from 180, you get 116. Take half of that, that's A, 58.
Okay.
This angle up here that's supplementary to B is also 58, because those are opposite angles of an isosceles triangle. Remember that when you're looking at an isosceles triangle, it's only the opposite angles that are equal. In other words, it's not this angle and A that are equal, it's A and this angle up there. So that's 58. B is supplementary to that. B has to be 122. Okay, if B is 122, and we've got parallel lines here, that means that this angle here that's made up of C and the angle above it, that's the same as B, right? In other words, we have these two parallel lines here, and this line right here is a transversal, and so C is the corresponding angle, not C, but two C's, because they're telling us this C is equal to the one above it, and we know that that C plus the one above it is equal to B. So what was B again?
122.
So that's half of 122. That's 61 is C. Oh, why are there two C's? Oh, this must be an E down here. Okay, so C is 61. This angle is 61. What is L as long as we're on it right now?
58.
Uh-huh.
No, yeah.
Yeah, because I think we got 61, 61, which is 122, and that one's 58. Unfortunately, I have a 4:30 session I'm going to have to go to, so I can't finish this problem up, but I think you can see how we're going and how to do it. Just kind of gradually work your way around the figure, seeing if you can figure out what these angles are. And you can definitely do it. In other words, F is the same as A, right?
Mm-hmm.
And so you can figure out F. And I'd have to think about it a little longer. You can figure out K is going to be the same as I. But anyway, unfortunately, I got to go. Allie? All right?
Yep.
Okay. I'll talk to you next Wednesday.
Okay, thank you.
Bye-bye.